Hey, it's Mr. Canfield. Today we're going to be solving equations with the variable on both sides. So this is section 1.3. And the way that this video is going to work is I'm going to do a series of problems and I'm going to teach through them. You are allowed to speed me up, you're allowed to skip through things, but make sure that you can handle this whole stack of problems. As long as you can handle all those, you get the lesson and you're good to go. If you need to pause the video, go rewind, that sort of thing. And I recommend taking your own notes, just like I'm doing here. So you might even want to set up the top of your paper like this, 1-3, solving equations with the variable on both sides. You don't have to write everything I write down, but in general in school, when the teacher's writing something, that's something we should probably write too. So here we go. This first equation says solve x plus 3 equals x plus 3. Remember, we want to find out what x equals. And in your brain, you might be like, well, let me try different numbers. And you start trying things like, well, if I put 2 here, well, that's also x, so that's also 2. Well, 2 plus 3 is 5. 2 plus 3 is 5. Wait, it's the same number. And we go through and we start to think of different numbers. You know what? I can't think of a number that doesn't make this true. And if you think about it, this says x plus 3, this says x plus 3. You might notice they're the exact same thing. This and this are the same thing. That means that x can be anything. So we'd actually say that x can be all real numbers. X could be all real numbers. So sometimes I might go too fast for you. If you need to rewind, you can, or you need to pause, you can. So that's that. Let's look at our next one. So our next one might not be as apparent what's going on here. It says 4x plus 4 equals 3x plus 6 plus x minus 2. So key thing with solving, before we ever solve, we want to clean up. We always clean up before we go to solve. So when I see this whole mess here, I go, wait, I should clean this up. And so I can do what we call combining like terms. And that's where I can say, you know what? Before we do that, let me introduce the barrier. There's the barrier. Remember, we don't cross this barrier without special solving moves. So this 4x and this 3x, although they both have x's, I can't just say, oh, I have 4 of them, I have 3 of them, that's 7 of them. No, there's this barrier. The equal sign is a barrier to that. But anything that's on the same side of the barrier, you can combine. So like here I have a 3x and I have a x. Wait, there's nothing on there. What is that? Oh yeah, it's a 1. Remember, when there's nothing written, it's a 1. So I have 3 x's and I have 1 x. Some people call this box and buttons because you can put a box. Anywhere I see an x, I can put a box around it. Here's another x, I can put a box around it. And then I can put a different shape, which we can call a button. There's my box, there's my button. So like plain numbers get a button. So how many boxes? Well, I got 3 x's, I got 1 x's, that's 4 x's. The memory I have of box and buttons is I had a student, real tough looking guy. We're doing this. And I'm like, all right, we're gonna do combining like terms. And he's like, what? And I like start drawing these shapes and he goes, oh, box and buttons. And I'm like, what? He's like, yeah, those are the boxes, those are the buttons. And this really tough guy, it's stuck in my memory. I'm always going to remember him because of that. It's adorable. Like, even tough people can think about things in simple ways and it's fine. Anyway, now I got this plus 6 and this minus 2. If you get stuck on that kind of stuff, remember, it's okay to go to your calculator and look it up. You would literally type in, well, there's no positive button. Plus doesn't do positive on our calculators usually, but I do 6 and then I do minus 2. And 6 minus 2 is 4. So I can say positive 4. So that's what's left over there. Oh, interesting. We got the same situation as last time. 4x plus 4. Those two things equal each other. If they ever exactly equal each other, well, x can be anything then, and they'll be the same thing. So this is another one where we can say all real numbers. All right. So I wanted to look at the weird cases first before we look at what these are rare. This doesn't normally happen. Here's another one. X plus 4 equals x plus 5. This is an interesting one. This is one where if you start to pick numbers, you might notice a pattern. You might notice, wait, some number, add 4 to it, and then take the same number and add 5 to it, and I want to get the same thing. And you might be like, wait, huh? So you might not quite be sure here, but if you try different numbers, you can't find one that works. There's no number ever where if you add 4 to it and then you add 5 to it, it's the same thing. And if that's not obvious, that's okay. But if you think about that, if you think, okay, let me start with the same thing. I'm gonna give you $5 and you $5. You both start with $5. Or both start with some amount of money. I'm gonna give $4 more to you and $5 more to you. Do you still have the same amount of money? No, it's not the same anymore. So starting with some number and adding a different amount, it's never gonna be the same. This one actually has no solution. And we can get that just from telling, oh, it starts with the same amount of x's, but then it adds different amounts. Here's the other way. What we can do is, well, there's 1x here and there's 1x here. Remember, to move across the equal sign, we do opposites. So this is a positive x here. I can subtract 1x here, subtract 1x here. 1x minus 1x cancels. Wait, 1x minus 1x cancels here too. We wind up getting 4 equals 5 and no more x's. If all your x's cancel out and that happens, that's not true. If you get something that's not true, that's called no solution. Just to jump back really quick, let's say we're here, 4x plus 4 equals 4x plus 4. What happens if we do this one? Well, if we subtract this 4x from this side, we also subtract it from this side. Cancel, cancel. Oh, we're left with 4 is equal to 4. Now we have a true statement. Something that's true once the x's cancel out is all real numbers. Like, think about that. It's always true. And then this other situation, this is always false. So, all right, we're gonna get away from that. We're gonna get into, this is a typical problem that we would see. A typical equation where there's a variable on both sides. Some people get really messed up when the variable is anything except for x. So, and like, I'm not talking like just in, like, we're in a CP class. I teach honors level math, I teach AP level math, and I see people struggle even at those levels with different letters. So if you're like, I can't think about you if you're Y, you need to be X, and you go in and you change those to X's, I will know what you mean. I'm never going to have a problem with that. I think it's worth pushing yourself and getting used to using different letters, but it's okay with me. All right, let's see. Pick a color. Did you pick blue? Because I did. All right. So in this situation here, I'm going to rewrite this, and I'm going to stick with the Y. I'm rewriting it just since I kind of scribbled on that last. Okay, so the first thing that we want to do, well, I'm going to draw a barrier. We've already tried simplifying each side, so simplify. That's the real first thing we do. And I look over here, there's only a single y and a single number. Over on this side, single y, single number. So there's no like terms on either side. Then our next step is we do any plus or minus solving moves. So, wait, but if I add the 14 to both sides, I have a 2y here and a 3y here. Like they're on different, there's more than one y. So we actually only want the variable on one side. So my recommendation is to take, if it's ever on the right-hand side, use our solving moves to get it from this side over to this side. So like I see this as a positive 3y. If I subtract 3y from both sides, let's see what's left over. Well, 3y minus 3y cancels. We get 11. That's a positive 11. You could write a little plus there. Over here, I have negative 2y and negative 3y. Now, we are adding and subtracting here. So since we're adding and subtracting, you could think about it like this. I've got a negative, two little negatives, 3 more negatives. Positives and negatives when we're adding and subtracting cancel each other out. But positives and positives, or negatives and negatives, actually build and they grow together. So how many negatives do we have total now? Well, we have 5. So this is actually negative 5y. That's really the only thing that's changed. And this minus 14 just comes down as it was. So I have negative 5y minus 14 equals 11. So now, if you understood how we did that, how we got this 3y and brought it over here using solving moves, now it's just a normal solve. So the real number 2, we want to add and subtract to get x on the left. Some of you might be like, well, I want to put it on the right. You totally can. Instead of subtracting the 3y, we could have added 2y to both sides, and that would have canceled it over here and brought it over here. I'm just trying to give you what most people are comfortable with, or more comfortable with. So, all right, so now that we're here, we just solve like we normally would, right? The first thing we would do, we don't pay attention to the y stuff, we pay attention to the plain number. We do the opposite of that. It's minus 14. So we'll add 14. So then, well, these guys cancel. And notice, it's a negative 14, it's a positive 14. Negatives and positives when we're adding and subtracting cancel each other out. Let's see, 11 plus 14, we get 25. And then I was supposed to, new stuff, I try to write in this color. And then we still have this negative 5y here. So then if I want to finish this up, I divide by the number that's touching our variable. I just divide by negative 5, divide by negative 5. Negative 5 divided by negative 5 is 1, and so we just have a y here. And over here, 25 divided by negative 5 gets us negative 5. You can use your calculator if you're not sure. You would type 25 division button, negative 5. And I can show you how to use our graphing calculator that we have on our Chromebooks today in class, or anytime you have questions, feel free. Okay, we've got a few more examples to do. I believe we have 2 more. Okay, so this one it adds an extra layer. This is, if we go back to our steps that I didn't finish. Simplify each side, plus minus, get x on left, and then we'll finish it up. Also, if you're wondering what color this is called primrose, or primavera, or primavera. All right. So 3 is solve normally. So you might notice these are not super mathy ways to talk about this. These are the notes that make sense in my brain. That might not make sense in your brain. Well, then do something different. Write something different. You want to write something that makes sense to you. So 1, simplify each side. Well, let's look at this. We've got 2 times the quantity, 3x minus 1, is equal to 17x minus 2. So if we look on the right-hand side, 17x minus 2, there's just an x and a number. We're good. Over on the left-hand side, there's a number, parentheses, some stuff. You should have seen this before. There's a way to handle this. It's called the distributive property. And what we do is we take the number that's out front, positive or negative. You always want to think about that when we're doing multiplying, when we're doing adding and subtracting. Positive or negative? Well, there's nothing. That means it's positive. Positive 2. This is just pink. This is normal. Not a fun name. Positive 2, and you take it and you're going to multiply it by both of those. So 2 times 3x, remember we just multiply the numbers, so 2 times 3 is 6, and the x comes with it. Then 2 times the 1, now we have to be careful. We have a positive 2 and a negative 1. What's a positive times a negative? And this is where if you're not sure, you could do 2 times negative 1 in your calculator, and it'll give us negative 2. So that's our left-hand side now. Our right-hand side is going to just be normal. Oops. I dropped that marker. It's gone forever. Okay. Oh, it's back. So this 17x minus 2 is still there. All right. So now if I want to get, all right, here we go. I'm going to, so I see, did that make sense? Let's try again. I have x over here, I have x over here. They're on both sides of it. So I'm going to take it and I am going to take the one on the right-hand side and try to move it over to the left-hand side. But how do I move this over there? I've got to use my solving moves. So don't get fooled by this 2 after it. What's the 17? Is the 17 positive or is the 17 negative? You always want to pay attention to the sign on the front of it. It's a positive. If you're like, Mr. Canfield, why are you telling me like a baby? I'm like, hey, we're gonna do this, we're gonna do this. Just deal, it's okay. So, sorry, I'm just gonna rewrite since I was kind of marking that up a little bit. So since it was positive, I'm actually gonna use minus to get rid of it because 17 minus 17 is how we cancel. And then I go over to the other side. Well, this has an x, so I'm going to actually subtract it from the x over here. So that's gone. Over here we have a negative 2. Over here, now 6 minus 17. It'd be really annoying if I went through and I was like, well, I have, let's see, 6 positives. It'd be really annoying if I did this. And then 17 negatives. And remember that when we're adding and subtracting, positives join forces, negatives join forces, but when the 2 are combined, they disappear. So like 1 plus and 1 minus cancels each other out. 1 plus, 1 minus, plus, minus. And so if I go through and just cancel, oh, I ran out. I did all that canceling. I ran out of positives. All I have is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 negatives left. So I could say I have 11 negative x's left. The minus 2 is just chilling. So now, let's see, negative 11x minus 2 is equal to negative 2. We'll just solve like we normally do. Well, it's a minus 2, so I'll add the 2 to both sides. Cancels. What's negative 2 plus 2? Well, if you're not sure, I have 2 negatives, 2 positives. Wait a minute. I ran out. I'm completely out. I have nothing. You know, there's a word for that. Or sorry, there's a number for nothing. It's a number for nothing. In money, in real life, that number for nothing is 0. I have nothing left over, and I have negative 11x. So now to solve, to finish this up, you might already know the answer. We're going to divide both sides by negative 11. 0 divided by negative 11 is actually 0. So x equals 0. All that work to find out that nothing is our answer. I mean, sorry, 0 is our answer. All right. One final one. And this is kind of our reach question for the day. It's our tricky question. At least it looks really, really tricky to start out with. So not only did I write t and then scribble t there, there's all these decimals. Well, there's a trick. And that trick is multiplying both sides by a number that gets rid of the decimals. And so how many places do I want to move these decimals to get rid of them? 1, 2. So what I can do is I can actually multiply this side and multiply this side. I can distribute a number to everything to cancel out these decimals. And if you recall from middle school, if I want to move a decimal point, like let's say 1, 2, 3, 4, 5. If I want to move that decimal point 5 spaces, I can just multiply it by that many zeros. 1 with that many zeros after it. So if you don't believe me, try it out. This should get you 4. If I messed up, maybe, let's see. 1, 2, 3, 4, 5. We should be good. That should get us 4. So here, we need to move them 2 places. I can multiply by 100. If I multiply both sides by 100, I'm allowed to do that. I'm allowed to multiply both sides by the same thing. Now the parentheses don't change, but the numbers out front do. And that plus 0.18 turns into just plus 18. Now, I still wouldn't say this is an easy question, but it's a lot less terrible. So now let's go through. We're going to simplify both sides, just like we've been doing. Bop, bop. So 3 times 2 is 6t minus, let's see, positive 3 minus 4. Positive times a negative is a negative, so yes, minus 3 times 4 is 12. Boppity bop. Over here, 6 times t. Wait, there's no number on the t. There's a 1. 6 times 1 is 6. T chills. 6 times 5 is 30. It's a positive times a negative, so it's a negative 30. Then a plus 18. All right, I just got a number, or a variable and a number. But on this side, I've got a variable and 2 numbers. So let me combine my like terms here. I've got a negative 30 and a positive 18. I could draw it out again. I'm not going to this time. Or I could use my calculator if I'm not sure. But if I think about this, I'm going to have lots of canceling. What's going to be left over? Negatives are going to be left over. How many negatives? The leftover after 18 of them get canceled. So if I really just think, okay, 30 minus 18, how much is left over? 12 is left over. That means I have 12 negatives left over when they cancel. 6t minus 12. Ladies and gentlemen, I did not know that this was going to happen. If you don't see it yet, that's okay. So now let's just keep on solving. Here's the beauty of this, is you don't have to be able to recognize it to solve this. I see a 6t over here. I want to bring it over to the left-hand side. Minus 6t minus 6t. Over here, it's gone. And I've got a negative 12. Over here, I've got my negative 12 and it cancels. Negative 12 equals negative 12. Guess what? Is that true or is that false? It's true. That means this has an infinite number of solutions. We can say all real numbers. It always annoyed me that there was this thing called a real number. I was like, what, are there fake numbers? No, but there are things called imaginary numbers, which is not a very good term. They're not actually imaginary. They are actually real existing numbers, but in math, we don't call them real. We call them imaginary. So I hope this was helpful. There's some practice that we're going to do after this. Yeah. If you have any questions, you know where to find me.